Lesson 3.14, what are the chances of both events? Union, intersections, complements. Goal. Students will learn mathematical language for calculating probabilities of unions, intersections, and complements of events. They will calculate probability of a union both through intuitive methods and using the addition rule. So here's what we do now, we do that in class. So here's our first problem. Election day is less than a month away, and political analysts are focused on the race for two statewide political offices. According to a recent poll, in the race for the governor, 40% of voters support the Republican candidate and 53% of voters support the Democratic candidate. In the race for Attorney General, 61% of voters support the Republican candidate and 37% of voters support a Democrat. Assume that the voter preference for the candidate of each of these options is independent of each other. What is the probability of a randomly selected voter supports both the Democratic candidate for governor and the Democratic candidate for Attorney General? So we want the Democratic governor for governor and the Democratic for Attorney General. We'll put it like that. Right, the odds of getting the Democrat for governor, it says right here, is 53%, so 0.53. And the odds of getting it for the Attorney General, for Democratic Attorney General, is 37%, so 0.37. And all we're going to do is multiply them. They're independent events. The way you solve independent events is you just multiply them across. So if you multiply that, you get about 0.196 or 19.6%. So like that. What is the sample space for all possible outcomes in the voter support for candidates of governor and attorney general? Now remember, sample space is just a list of possible outcomes that we could get. So for governor, we could get Democrat, Republican. For attorney general, we could get Democrat and Republican. So it's all the combinations of that. So we have a Democrat, we have a Democrat and Republican. We could have Republican, Democrat, and Republican. Now, that normally would be it, like those four choices. But if you noticed, governor is 40, and the Republican is 40, and the Democrat's 53. That only adds up to 93%. Same thing down here. Attorney General, right? 61 for Republican and 37 for the Democrat. That adds up to be 88. I can do math. 88, 98. I can do math sometimes. 98%. So there's an other choice. I'll put other, or like an independent candidate, honestly, probably put. So that's a few more possibilities. So we did Democrat, Republican, Democrat, Republican. Now we got to do the same thing for the other Democrat, other Republican, other. And then we still got to do the Democrat other and Republican other there. And I believe that's all the choices. So that was definitely tricky. Like, I would have stopped here if I didn't realize, like, wait, it didn't have to be 100. And you always have to be 100. So if we were doing like the area model, you would have noticed, like, wait, it doesn't have to be 100. I need 100. So Democrat, Republican, other. A set of outcomes, a subset of a sample space, is called an event. So events are just like one of these guys, like whatever one you want to happen. So what's the event of a Democrat, or event of other Republican? That's what an event is, one of these outcomes. Which outcome from the sample space are in the event support Democratic governor? So that first question. So support Democratic governor. So remember that the way I did it was the first one. So the events are, anytime there's a D in front, is the support Democratic governor. So DD, DR, and DO. Those are the ones that support the Democratic governor. Which outcomes in the event support the Democratic Attorney General? So again, the way I wrote this, that was the second D. So the first one was for governor, and the second one for Attorney General. So that's DD, RD, and OD. So those are the events of supporting the Democratic Attorney General. So the second D in the list. The intersection of two events, A and B, in the event consists of all outcomes are both A and B. If you have not done so already, create an area model for the situation. What outcomes? So we have to create it. Let's do that first before we run out of space. Area model for the situation. So I'm going to do this over here. With that, I was hoping to make it a box. And then remember, we're going to have governor on top, I guess. And we'll put Democrat, Republican, and other. Odds of them supporting a Democrat is 53, Republicans 40. And that makes the other, we did this earlier, 93, so 0.07. So again, right, this is just the way I figured out. It was 1 minus 0.53 minus 0.4, and I got 0.07. 7%. And then we're going to do the same thing for Attorney General down here. So Democrat, Republican, and other. The Democrat here is 30% of voters, and Republicans getting 61. So 37, 61. And if I want to find the other there, I'm just going to do the same thing. 1 minus 0.61 minus 0.37. That's 0.02. And then we're just going to make an area model. I'm not going to do this one as perfectly. I tried a little bit for the first one, but I'm just going to do this. I tried to make it kind of like a real area model. I probably should find them all equal. And then remember, to get these values, we have to multiply. So Democrat times Democrat. So here times here is I'm just going to put in my calculator, 0.1961. And then Republican times Democrat will get me 0.148. And then other times Democrat will get me 0.0259. Let's go down the list, right? Democrat times Republican, 0.3233. Republican times Republican, 0.244. Just putting it in my calculator. Other times Republican, 0.0427. And then Democrat times other would give me 0.0106. Republican times other, 0.008. And then other times other, super small chance, 0.0014. Okay, so there's my area model situation. What outcomes are an intersection of events, the Democratic governor and Democratic attorney general? How can this be seen in your model? So the intersection is what they both have. So if you look up here, right, what are the ones I have for both of them? I think the only one I have for both of them is Democrat, right? That's the intersection. I support the Democratic governor, so the D in the front, and I support the Democratic attorney general, which is D in the second. So the only one that does that is this Democrat, 0.961. It's the only one that does it. So we'll put DD. Okay, E. Shade your area model to highlight the event Democratic governor. So let's do that. I'll do that in orange. So Democratic governor is the top one. So like this portion. I can make that even. There we go. Like that. And then shade your area model to highlight the event Democratic attorney general. So that's this way. So this one was this one, that one. So there we go. What do you notice about the intersection of events? The intersection of events it's my DD. The intersection got intersected twice. It was shaded twice. So this one shows another way to find it, right? So you just go Democrat and Democrat. That's the one I want. That's how you find probably everything you want. 36. Darren is a Democrat and is really hoping that Democratic candidates will win at least one of the offices. Darren tells his friend, Antonia, since the Democratic candidate for governor is supported by 50% of voters and the Democratic candidate for attorney general is supported by 37% of voters, that means 90% of voters support the Democratic candidate for governor or attorney general. Antonia says, well, if that is true, then 101% of voters support the Republican candidate in the general election. Good retort. Is there anything correct? Why or why not? So, I mean, as Antonia rightly pointed out, he's not thinking correctly. Using the same logic, she would have got 101. I think he's forgetting that the events overlapped. That's why you get more than 100 sometimes. The events overlap. So the same people you're kind of the same people twice. That's the issue. Overlap. Sorry, spelled like that. The union of two events, A and B, is events consisted of all outcomes of either in A or in B or in both events. What outcomes from the sample space are in the union events? Democratic governor, Democratic attorney general. How can this be seen in your area model? So the first part, in our sample space. So remember, union means what it says here, either A or B or both. So it's generally saying it's A or B. I'm happy with A or B. So I want Democrat in the front or the back is fine. So this one counts. This one counts. It has a Democrat in the front or back. So does this one. So does that one. And so does this one. Right? All 5 of those have a Democrat in the front or in the back or both. So that's what a union means. It's in the front or in the back. Like it's in either space. So that one. Democrat, Republican, Republican, Democrat, other Democrat, and Democrat, other. How can it be seen in the area model? So that is all of these, right? So Democrat, it's the column and row of Democrats. See here, this is a column of Democrats, and that's the row of Democrats, and all those would be an OR. So in the area model, it's the row and column of Democratic. What is the probability of the union of 2 events in Part A? That is, what's the probability that a random selected voter supports the Democratic candidate for governor or the Democratic candidate for attorney general? So that's, all we're going to do is add up all those probabilities here. So we're going to add up that, plus that, plus that, plus that, plus that. So we're going to add up 0.9611 plus 0.148 plus 0.0259 plus 0.3233 plus 0.0106. If I add them all up, I'm going to get about 0.7039, or about 70.36%. So that's how that works, right? You just add up all those columns. What's the probability that a random selected voter supports a Republican governor and a Democratic governor? So that's a Republican governor and Democratic attorney general. So that's Republican governor, Democratic attorney general. So we want Republican governor, so we want this column, but we want a Democratic attorney general, so this column. So the overlap is right there, 0.148. That's a Republican governor and a Democratic attorney general, so 0.148. Or if you wanted percentage, 14.8%. What's the probability that a random selected voter supports a Republican for governor or a Democrat for attorney general? So it's the same idea. Let's see if I can go back up here and delete some of these colors. Okay, well, did the best I could. So we want a Republican for governor, and then we want a Democrat for attorney general, or a Democrat for attorney general. So it's the same concept. We're not doing the overlap, we're doing the union. So I'm going to add up all these numbers. So 0.961 plus 0.148 plus this, plus this, plus this. When it's an OR, you add up all the numbers. When it's an AND, you add only the overlap. So we're going to add up all those numbers. And if when I do that, I should get 0.622 or 0.62.2%. Remember, I got that from adding up all the numbers. So if I went 0.1961 plus 148 plus 0.0259 plus 0.244 plus 0.008, I would get 0.62 or 62%. Okay, let's go on to another one. Viola described the following method for calculating probability in Part E, Prompt 236. So she's talking about this part. She wants to calculate Republican governor or Democratic attorney general. So remember, we got 0.622 for that. So she said all the outcomes for voting preferred a Republican governor and all the outcomes for voting preferred Democratic attorney general. Just like we did. So she did the same shading, like this and like this. But I noticed that there was some outcomes that were shaded twice. So I just added the original probabilities and subtracted probabilities from the overlapping outcomes. And she got 6.22. That's the exact same thing we got. Does Viola's answer match the answer from Part 2? Yes, it does. Right, so what she did was the difference is, so when we did it, we just added up, okay, this plus this plus this down here. So she just added up like this row, so 196 plus 148 plus 0.25, and then this row, 1.48 plus 0.244 plus 0.008, and then she just subtracted this off because it was counted twice. That's what she did. So that's how it compares. Will Viola's method always work? It should, because you're just counting the same numbers. You just instead of not counting the thing, when we did the first time, right, we didn't count the overlap. We just counted it once. She counted twice and then subtracts it, so it's the same. So yeah, it should. Yes, it should always work. Viola's method of adding probabilities and tracking the probabilities of the overlapping event is called the addition rule. It can be written like this. So it's a rule. So probability of A or B, so that's the union, equals probability of A plus probability of B minus the intersection, right? This is the overlap. So that's what this is. This is the overlap. And this is the union. This is also known as the intersection. You already seen that any event where A or B occurs is called a union, and it is said A union B. The event where both events A and B occur together is called an intersection. So the addition rule can also be written like this, right? Going in words, A union B equals probability of A plus probability of minus probability of A intersection B. Using the addition rule to calculate the probability that the third-party candidate will be elected for either governor or attorney general. Then check your results using another method. So we want probability of other governor union, we'll put it with a U, other attorney general, which is probability of other governor plus probability of other attorney general minus the intersection. Other governor intersection, or and other attorney general. Okay, so other governor. So other governor would be right here. So we got all these up, but it says 0.07. That's odd. Another governor, 0.07. Other attorney general. So we got up all these, or it's just this value here. They let us know 0.02 minus the intersection. So where those two things overlap, and they overlap right here for us, right? Other governor, other attorney general overlap at 0.0014. So that's what we're going to subtract off. Because in that case, that's the thing that's been counted twice, right? Let me go up here. Back here. Sorry for all up and down. 0.07, how do you get that? It's this plus this plus this. How do you get 0.02? It's this plus this plus this. So we count the 0.004 twice, so we're going to subtract it off, just like Velma's method. If we do that, we should get 0.0886. If we want to do it another way to check our results, right, so we can do what we did last time, where we just add up all the values. If we add up 0.016 plus 0.008 plus 0.014 plus 0.027 plus 0.0259, put in my calculator, and we do get the exact same thing. So you get 0.0886 again. So it does work. That's nice to know. Last one real quick. Sometimes it's easier to figure out the probability that something will not happen than the probability that it will. When finding the probability that something will not happen, you are looking for the complement of it. So complement of A means not A. Right? I don't want A to happen. What's the odds that A does happen? Complement of a set of outcomes in the sample size are not included in the event. Show two ways to solve a problem below, then decide which way you prefer and explain why. Now this first problem is a question we actually haven't done, so I'm going to change this real quick. Probably that we don't want to vote for a Republican governor. So not a Republican governor. So we're going to do two ways. The first way, the normal way we would do it earlier, which was like, hey, you don't want a Republican governor? I don't want this column here. I'm going to add up all the rest of the columns, right? So I don't want Republican governor to add up the rest. So I'm going to go down here. I'm going to add up 0.3233 plus 0.1961 plus 0.0106 plus 0.0427 plus 0.0259 plus 0.0014. If you're wondering where I get those numbers from, that's everything that's not that. So one was the Democratic column, which is this right there. It's my first array I set down, and then the other one's the other column, the next array I set up. And if I add those up, I get 0.6. Now, what's another way to do this? Well, if I don't want the Republican, I could just do 1 minus the probability of getting a Republican governor. What's the odds of getting a Republican governor? 0.4. Remember, this is getting Republican. This right here, 0.4. So let's take that away. I don't want that. Remember, the total is 100, so minus that, 0.4, and I get 0.6. And you can decide which way you like better, but I would take the one that's a lot less work, which is this one. So you just, if anytime you want not something, the complement, you just subtract 1 from that thing, or that thing from 1, because you don't want it. So total is 1, take it away. If the probability of event A is represented by the symbol probability of A, how can you symbolically represent the probability of a complement of A? So if we want that, the complement of A will be the same thing we just did, which is if I don't want, I subtract it from 1. So the same thing here. If I don't want A, of the complement of A, so subtract 1, that from 1. And that's how you get the complement of A. 1 minus probability of A.